Hello students, welcome to the next screencast. This one we are going to be solving polynomials. Alright, but we're going to do it in a real world context so we see how this is used. We're making a scrapbook. You plan to make a scrapbook. On the cover you want to show 3 pictures, 1, 2, 3, maybe you know those people, with spaces between them as shown, little tiny spaces between them as shown. You see those little distances right there? And they're measured and labeled and everything right here for us in the picture. Each of the pictures is twice as long as it is wide. That makes sense because according to this picture, if we look right here, this picture is labeled, it is 2x in width, and if it's twice as long as it is wide, well then 2x times 2, in other words twice as long as it is wide, would be 4x. So it is twice as long as it is wide. Okay, so it's labeled accurately for us. The first part says to write a polynomial that represents the area of the scrapbook cover. Then the second part is the area of the cover will be 96 square centimeters. Find the length and width of the pictures you will use. Alright, we'll do that of course after we tackle part 1, in which we have to start by finding and writing a polynomial that represents the area of the scrapbook cover. Now, one thing, of course, we remember is that the area for any rectangle, and that's what this shape is, of course, the area would be the length times the width. So in order to find the polynomial that represents the area of this cover, we have to find first the length, then the width, because we don't know that just yet. So let's get into that. But first, I mean, this is kind of small, I would say. Let's kind of blow this up, and so maybe we can kind of rewrite it and rework it to see what we're dealing with here. You know, I think what would help us is if we looked at this, in more detail, if we looked at this a lot bigger, okay? So here we can see it a lot clearer now that it's larger. And, with all these numbers kind of scattered everywhere and these variables and even these pictures in the way, it's not going to really be conducive for us to see what's going on here. Here, I'm going to redraw this. See, what I've done is I've kind of made a skeleton version of this picture right here. As you can see, each of these rectangles in the middle, the pictures are represented here, here, and here. And so without all the colors and the spiral and the green, it just looks a little bit better for us, and it's probably going to help us to label it a lot better. Let's talk about, let's talk about the length first. In other words, the distance from here to here, that bottom side or that top side. The length, all right? If we know that this is the length, let's figure out how we can accurately create something that would represent how long this side, this length would be, based on these numbers here. Now, if we start all the way over here at the edge of the scrapbook cover, we see that the distance between the edge here to the first picture is only 2 centimeters. So it's right here to here is 2 centimeters. And I'm just going to write 2. We'll put in the label last. Then what we see is that, well, what about the distance between right here to here within the picture? It doesn't really say that right here in this picture. But if we know that all 3 of these pictures are going to be the same length and width, in other words, equal size, we know that the distance from here to here, this little tiny distance, is of course the same distance as here to here. Now, on this picture, it is labeled the distance from here to here. In other words, the width. The width of this little tiny picture seems to be, where is it? There it is, it's 2x. So let's label this distance right here 2x. Alright, let's keep going. The distance between the first and the second picture is only 1 centimeter, so 1 centimeter. The distance from the width of the second picture is the exact same 2x as the first one, and heck, let's just write it in for the third one as well. We know that's also 2x. And the distance, as we can see, between the second picture and the third picture is another 1 centimeter. And the distance, the final distance, from the last picture all the way to the edge, the other edge of the scrapbook cover, is once again another 2 centimeters. So there's another 2 centimeters. So look, what we have here is we have this complete length right here, represented by a 2 centimeter, a 2x, a 1, a 2x, a 1, a 2x, and a final 2 centimeters. So how is it that we would figure out this entire line's length, in other words, the entire length of this scrapbook cover? Well, if we broke it up into pieces, all we'd have to do is add all of these little tiny lengths together. In other words, we just simply need to add all of these numbers together and we will have the total length. Alright, so let's do that. Let's see here. We got a 2 plus a 1 plus a 1 plus a 2. Well, we know that, of course, is going to be, that's right, 6. And then we also have the other like terms, the 2x, the 2x, and the 2x. So we have three 2x's that we're adding together, so of course that's now 6x plus 6. So now that we know that the length is 6x plus 6, that's a good start. That's a very good start. So we know the length. Well, now we have to determine the width. And to do that, we use extremely similar logic. Now we're calculating the distance from here to here, the top to the bottom, if you want to think of it that way. You know, the width. So we know that this side is the width, so we'll label that W. Well, let's see here. If we start at the top here and we go down to the first top of the first picture, we see that is also, 2 centimeters. So we'll put a 2 right there. And what about the entire length of the picture? Well, once again, this first picture, it's not labeled here, but since all three of these pictures are equal, we can clearly see that, oh, look at this, 4x represents the length of not just this last picture, but also this first picture and this second picture here. So it's 4x this time. So from here to here, that is 4x. And then we only have one more distance to figure out. It's the bottom distance here. It's from the bottom of all the pictures to the bottom edge of the scrapbook cover. And as you can see right here, it is labeled as another 2 centimeters. So here is another 2 centimeters. Okay, so now we simply, yes, like before, we have to add all these together. And there's only three things to add together this time. There's the 2 plus the 4x plus the 2. Alright, so if we add 2 and 2, we get 4, and then the 4x kind of stands alone because it's not a like term with that other 4. So we clearly see that the width is now 4x plus 4. So look, we now have the length, 6x plus 6, and the width, 4x plus 4. Nice work. And you saw that we were able to get that by kind of taking the picture that they gave us and rewriting it and kind of making a skeleton version of itself and relabeling it all to suit our own purposes. That's always a valuable thing to do with any mathematics problem. Now that we clearly see that the length is 6x plus 6 and the width is 4x plus 4, we can use the tried and true area formula of this rectangle, which is length times width, in order to figure out a polynomial, a single polynomial, that would represent the area. It wouldn't be exactly the area, but it would represent the area, basically knowing that we have some unknown variables, namely x here. So let's go ahead and do that math. The length is 6x plus 6 multiplied by 4x plus 4. And in order to solve this, of course, we have to, that's right, we have to take 6x times 4x. You're going to see a lot of deja vu coming your way right now. That's 24x squared, and then we have to do 6x times 4, and we know that's 24x. And then we have to do 6 times 4x, well, that's going to give us the same exact 24x. And then 6 times 4, well, that's just going to give us 24. A lot of 24s in that. You see what I mean by deja vu? Well, now let's put together some like terms. We've got 24x squared. That stands alone because there's no other like term with it. But these two 24x's added together, as we know, make a positive 48x. And then this final term here, 24, with a degree of 0, stands alone on its own as 24. So, look what we have here. We have just created a polynomial that represents the area of this scrapbook cover based on the fact that we figured out that the length was 6x plus 6 and the width was 4x plus 4, and we multiply them together, and our polynomial is 24x squared plus 48x plus 24. We are done with the first part. Write a polynomial that represents the area of the scrapbook cover. Fortunately for us, this polynomial is going to come in handy as we now try to find the length and width of the pictures that we will use. And the pictures we will use are going to be these three pictures, and we have to find the length, this way, and the width. And we know the length is 4x, and we know the width is 2x. Well, we have to really just figure out what x is, because once we know what x is, we can figure out the length very easily. And once we know x, we can also figure out the width very, very easily. Alright, so let's do that. You see, based on the polynomial we figured out just a few moments ago, we now need to figure out the length and the width of the pictures we will use. The area of the cover will be 96 square centimeters. That's extremely helpful. You see, we just created a polynomial that represents the area. It's this, 24x squared plus 48x plus 24. So if this polynomial is the area, and it's now telling me that the area is also 96 square centimeters, then what we can say is this polynomial representing the area is, in fact, equal to 96, because they're both representing the same thing, the area of this scrapbook cover. And as I just said moments ago, if we find x, we will know that to multiply 2x and to multiply 4x, we'll get the length and width of the picture that we're going to use, thus effectively solving the question. Well, here's the question though. How do we solve for this x? Well, this is a polynomial, and it's equal to 96. So we have to solve this polynomial for x. Now, how do we do that? Well, the first rule when solving polynomials, remember what we said? You can only solve a polynomial when it is equal to, that's right, 0. It's not equal to 0 right now, it's equal to 96. Well, no problem. If we move this 96 over this way, then it will be equal to 0. So let's subtract 96 from both sides. And of course, we're going to subtract the 96 from the 24 because those are the like terms. And so what do we get here? We get 24x squared plus 48x. 24 minus 96, aha, negative 72, is now equal to, well, 96 minus 96, 0. Now it's a polynomial that is equal to 0, and we can now continue to solve it. Wow, okay, so 24, negative 72, AC, I got to use the AC method. 24 times negative 72, big number, not a fan. I mean, we could do it that way. Or we could remember that really important trick, that first commandment, when you're factoring, is to see if you can factor out a greatest common factor. Is there a greatest common factor between 24x squared, 48x, and negative, mind you, negative 72? I'll take a moment to think about that. Because if you said, the number 24 itself, congratulations, you were correct. We need to pull out a 24, factor that out. And now watch as the polynomial that goes inside the parentheses that we will be continuing to work with becomes oh so much smaller, oh so much more manageable, and oh so much easier to work with, folks. I can't stress enough. If you can factor out a GCF, then do it. It's going to make your life a whole lot better. This 24 that's out in front now, see, that's still going to be there the whole time. It's just going to keep coming down, down, down with every new line of my work. So we got to ask ourselves, since we factored out the 24, 24 times what will get me back to 24x squared? That's right. 24 times what will get me back to 48x? That's right. And finally, 24 times what will get me back to this negative 72. Very good. Negative 3. And that whole thing is still equal to 0, mind you. All right, now look at how much easier this polynomial that we, of course, still do have to continue to factor is now compared to this original. Now, don't get me wrong. If you were to use the AC method right here without factoring out a 24, if you did your math correctly, you will still get the same answer as we are about to get, except you're going to be dealing with much larger numbers. And if you ask me, working with much larger numbers leaves more room for error, calculation, or computational error. Well, fortunately, now we're just working with x squared plus 2x minus 3. So we just have to continue factoring that. And as an added bonus, notice that the coefficient in front of the x squared here is only the number 1, that phantom 1, which means we don't have to use the AC method. All we have to do is use that second method that is just asking ourselves what two numbers can multiply to get negative 3, and yet those same two numbers can add together to get a positive 2. Now we know to start us off, the term that goes here and here is based on whatever is this first term, and of course the only way to get x squared is x times x. So now we have to fill in two numbers, once again, that multiply together to get negative 3, yet add together to get positive 2. Let's see here. You know, you're probably thinking of it right now. Positive 3, negative 1. And it must be positive 3 and negative 1 because positive 3 times negative 1, that does give me negative 3. And the only way to get a positive 2, right, positive 2, is to take a positive 3 and add with it a negative 1, essentially saying 3 minus 1. Very good. Now don't forget that 24 still comes out in front, and the whole thing is equal to 0, and voila! Look, it is completely and utterly factored. 24 is a factor, x plus 3 is a factor, and x minus 1 is a factor, and the whole thing is equal to 0. We are almost done with this problem. To finish it off, what we need to do is recognize that the only way that any equation can be equal to the number 0 is that if one or more of its factors are themselves 0. So we have to apply all cases in which one of these three factors would in fact be 0. In other words, either 24 could be equal to 0. Now I know that's a ridiculous statement, and we'll talk about that in just a moment. Or x plus 3 is equal to 0. That's a little bit more easy to manage and digest. Or x minus 1 is equal to 0. So we have three different choices. Okay. But because this is a real world problem, in other words, we're trying to find the length and width of an actual scrapbook. In other words, actual real life distances, or lengths as it were. Typically the word distance is for a long distance and length is for kind of a shorter, if you take my meaning. So therefore, what do we know about lengths and distances? They can be decimals, sure, that's no problem, but what they can never be, the laws of physics will not allow, they can't be negative. Okay, so we're going to, I know this is going to sound strange, what we need to do is we need to go look at our work here, and we need to figure out what does make sense in the context of our problem, and what doesn't. And if it doesn't make sense, we quite literally throw it away. We don't need it. We don't need it because it doesn't make any sense. So let's see here. We can see right from the start, 24 is equal to 0. Yeah, 24, no matter how hard it tries, will never be equal to 0. So this is a ridiculous statement. So no, that's not going to be part of our solution. 24 doesn't equal 0. Throw that away. Let's solve this little other mini equation right now. X plus 3 is equal to 0. So x is equal to negative 3 centimeters. Huh? As I just said, and as you've known for a while, is that you can't have negative distances. So this answer right here, this solution, while it makes sense mathematically, in the real world, nope. You can't have a negative distance. So x could not be negative 3 centimeters. Which means we only have one option left, and we're praying to God that it is a positive number. Because if it's not, then we did something really wrong. But lo and behold, look at that. If x minus 1 is equal to 0, then x can only be one thing, 1. In other words, 1 centimeter. Ding, ding, ding. We finally have our answer. That's correct. X is 1 centimeter. But that doesn't answer the question just yet now, does it? I mean, it's the final component, the final piece to what it takes to answer the question, so let's do just that. Which means now, if we go back to our kind of enlarged version of our scrapbook cover, we now know that x is equal to 1 centimeter. We just figured that out. Okay, so now I want us all to kind of look carefully once again at what we're trying to figure out. The question asks us to find the length and width of the pictures. Well, if the width of the picture is 2x and the length of the picture is 4x, and we finally, after all of that, now know that x is equal to 1 centimeter. Wow, 1 centimeter? They couldn't have made it a different number? It seems so anticlimactic using the number 1 as the solution or part of the solution. I know. Basically what we now need to do to figure it out is we simply need to plug in the number 1 wherever we see an x. If 2x is the length, and therefore that would mean 2 times 1 is equal to 2 centimeters. And 4x, well, that would be 4 times 1 is equal to 4 centimeters. Woo, we did it! So therefore, the length of the picture is 4 centimeters, and the width is 2 centimeters, and lo and behold, we now finally have our answer. Nice job. Nice job. That's our final answer. All right. That's the problem I wanted to show you. Congratulations on learning that. Here is a similar problem, and it's for you to solve. Now this one's about wallpaper. Now, like I said, it's similar in the sense that you will be creating a polynomial, and based on the area given, you need to find the dimensions. You trimmed a large strip of wallpaper from a scrap to fit into the corner of a wall you are wallpapering. You trimmed 15 inches from the length and 6 inches from the width. The area of the resulting strip of wallpaper is 684 square inches. That's going to be an important piece in just a moment. If the length of the original strip of the wallpaper is 4 times the original width, okay, so if the original wallpaper is this kind of outline, this sort of like ghost of this stripped, cut piece of strip wallpaper, then it's saying if the length of the original strip of wallpaper is 4 times, so 4x, the original width, so the width is x, and the length is 4 times that, write a polynomial that represents the area of the trimmed strip of wallpaper. The trimmed strip of wallpaper. And that's part A. Part B is what are the dimensions of the original scrap of wallpaper? Of the original scrap of wallpaper. Alright, so basically what you're doing is you're trying to solve x. Once you have x, you're in good shape. There it is, folks. That's your problem. Good luck. Let me know if you have any questions. Have a great day.